So today in this video we are going to talk about the journey of a web page. Journey of a web page. Uh, we will be discussing what happens when you go in your browser window and type www.microsoft.com. Uh, what happened in your computer and what happens outside of the network. So in this journey we will talk about a little bit on a higher level the OSI model and about the gateway, DNS, and then maybe Akamai caching, how that thing works, and then discuss IIS pipeline. This is Windows web server, and then maybe we'll go till database. So these are the things we're going to talk about on a very high level, but this will give you enough pointers to dig deep into one of these areas. So let's see what happens when somebody goes, here's the user, and he types in his computer www.microsoft.com. So before anything happens, I want to discuss basically each and every layer coming in the picture. So before anything happens, in the browser itself, it's made up of a couple of pieces. The UI layer is there, and then there's a browser engine is there, and below the engine you have rendering engine, which comes in picture when the request will come back with the data, and then below that you have networking components, etc. So this is the journey is taken by your request to go through these components, and when we come to the networking, and from there it goes the call basically goes to the OS level, operating system level, and maybe this is a good place we can talk about OSI model. OSI is Open System Interaction Model. It's an abstraction layer of communication systems. You don't have to know about this because your application is sitting on top of the application layer itself. So there's a first layer in OSI model is application layer. Below that is a presentation layer. I'm just talking about them OSI model here, so you will get an idea that how the request goes through out of your machine to the internet and how the data come back. So what all pieces are involved in the middle. So you need to know this thing if you are an operating system or a network driver developer, but as an application developer you don't need, but it's just very interesting to know about, like presentation layer, what does it do. So presentation layer basically gets the data from the lower layer and does the character encoding and data compression, encryption and decryption, all this it does, and then pass the data to the next layer, which is application layer. So below presentation layer you have a session layer. Now all these layers are basically divided into different component DLL and EXEs in your computer, but as I said, this is an abstraction layer. You basically take this networking framework to implement protocols to do the communication with the outside world. So this session layer, this is the layer which sets up the session between different different entities. So they have a client and server, and when we are making a call, you are basically setting up a session with Microsoft.com. If you type Microsoft.com in your browser, and below session layer, then you have a transport layer. This is the layer where we talk about all the protocols is defined here. UDP, there's a protocol called UDP, and there TCP. This is the layer which makes sure that reliable transmission of your data is happening. Now there's a two protocol called UDP and TCP. The big difference between these two is TCP is very connection-oriented protocol, and UDP is connection-less protocol. It's all about broadcasting, and TCP is guaranteeing that your data is delivered. It does the handshaking and makes sure the data is delivered. Otherwise, it's retried and all. So on under UDP, there are a couple of other protocols are there. One is like SNMP, which is a simple management protocol. It collects data about the infrastructure. There's another one is NTP. It's network time protocol. That's how the clients sync the time with the server. And in TCP, you have FTP and maybe TFTP. TFTP is trivia file protocol. Basically, there's no password and username. And then you may have SFTP, which is secure file transfer protocol. SSH is there on this protocol, and there's all other mailing protocol, which is like SMTP and IMAP4 also sits on TCP. And then there's a couple of protocol which can be on both of these, UDP and TCP. One is LDAP, which is Light Directory Access Protocol. And below transport, then you have this network layer, which is basically figuring out about your packets, addressing and routing and traffic controls, etc. And below that, you have data link, and after that, you have a physical layer. So data link is about reliable transmission of data frames between two nodes connected by a physical layer. Physical layer is transmission of, and reception of raw bit stream over a physical medium. So these are the abstraction layer. You don't need to know about them, but it gives you a pretty good idea what other components are in the picture when you hit enter, how the data goes out. So first thing happens is the data from your computer goes out and try to connect to a gateway. Gateway is nothing but a router, and every computer which is connected to network or internet has a gateway. Whether your computer is in home or in office, you will have a gateway. Gateway basically it's a router, so the main job of a router is to connect to different networks, and the router is in the between to route the calls between two different networks. So from gateway onwards, you start going to the out in the internet, and this is your this side, left side is your network, and this is the outside. So the gateway takes your call, and it goes to a DNS because you type Microsoft.com on your computer, but the computer doesn't know what does Microsoft.com mean. So they go to DNS asking what is the address of this Microsoft.com. Think DNS as a phone book, a phone directory for the internet, and they tell you what is the IP address of Microsoft.com. And if this DNS doesn't know the answer, then it will go to the next DNS, and that's why it does a recursive lookup. And if that DNS doesn't know, they end up reaching to a root DNS. There are these 13 DNS servers are there. They are called root DNS, and they have all the information. So once you reach to the root DNS, you get the information and it comes back. Now, how the information is laid out in DNS, at the end, it's a plain vanilla directory structure. So this is Microsoft.com, and then here is the say 122.34.55.3 is the IP address. This is the lookup happens in DNS. But how the information structured in DNS, on the top they have a root node, and it's just a dot. This is root, And below root, they have top level domain, which is like com, net, org, etc. And under com, they may have Microsoft.com, and under that, they can have maybe stores.microsoft.com or msdn.microsoft.com. So this is domain here, and then you have this host address, which is sometimes called subdomains also. So when you type Microsoft.com, it comes to the dot, which generally you don't type at the end, but this is how it comes back looking at your address. So Microsoft.com, it travels from the right hand side, gets to the com, then Microsoft.com, and then if you have stores or anything, then it will reach to this, and then they will get the IP address, and they will return the IP address. In DNS, there are different kind of records are there. One record is called A record. This is basically what I talked about here. Like you give Microsoft.com, and it gives you the IP address. And then you have a quad A records. They are basically same like A record, but they are for IPv6. So A record is IPv4. So big difference between IPv6 and IPv4 is IPv4 is 32-bit and IP6 is 128 bits. When the internet started sometime in mid 80s, they used to have a human sitting in some office where you used to call and give them your domain name, and they'll give you the IP address. So that time, IPv4 of 32-bit was more than enough. It's like a couple of billion addresses can be there. But very soon we have realized that's not good enough, and now we move to 128, which is IPv6. And IPv6 can give you billions of people, billions and millions of addresses. So it's 2 raised to power 128. It's a pretty big, huge number. Other than A record and quad A record, they have a CNAME. A CNAME is it's a canonical name record. Basically, it's an alias. We will see how the CNAME comes in picture when we'll talk about Akamai caching. So let's see what happens here. Now from this DNS, we know the IP address, and it goes back to our machine. And after getting the IP address, we come back and try to go to Microsoft.com. Suppose the server is here, Microsoft.com server, and we jump and hop through different server to reach to Microsoft.com. And you can see what servers we are hopping through in the internet world if you will type this trace route command, and with the domain name, it will show you all the servers are coming in between. Now, before we reach to the main server, we hit in middle Akamai server. Akamai. This is a CDN. CDN means it's a content delivery network. And what they do is they copy the content from Microsoft.com, and then they distribute this content all around the world. They will have servers everywhere, like in Australia, China, Europe, South America. So if somebody is hitting Microsoft.com from China, they don't have to come all the way from China to Microsoft.com in America, but they can hit a Akamai server in China. So how the Akamai server comes in the picture. So what happens, we talked about CNAMEs. So when DNS returns the IP for Microsoft.com, it looks at the CNAME also, where we have set up in the DNS that Microsoft.com will have a CNAME called Akamai dot cache or something, you know, their server names, and that's what is returned to the machine, that this is the IP address, which is basically a CNAME for the Akamai server. So when the call comes to Akamai server, it looks at the what is the URL and figure it out with that. If they have the information for that URL, they will return the information to the computer. But if it does not find that information with it, so they have a big, basically it's a big cache store. Everything is in memory there. That's why they're so fast. So if they don't have that information, they will go to the origin to get that information. And that's in the configuration of Akamai, where we say, for if you get a call from Microsoft.com, this is your origin address. So that's how slowly Akamai will start filling up with all this information. Now, once they hit the server, what happens here in the server, we have a process called HTTP sys. This is a kernel level process. It is just sitting and listening to all the call coming to Microsoft.com. And this process looks at the call and says, okay, I have already the data in my own cache. So it has a small cache here. And if it has the data, it returns. But if it does not have the data, then what it does, it has two more actors working with him. One is called www services, and other is WAS, WAS, Windows Activation Service. So www services basically looks at the configuration, app pool and all, and give the configuration to HTTP sys, and WAS is Windows Activation Service. So when the WAS gets a request from HTTP sys, what it does, it starts a worker process. And here's the worker process. This worker process is created by WAS to process all the requests. And this worker process have a pipeline kind of a setting where it has different kind of modules. So these modules are already existing, and they process the different aspect of the request. So we can have a HTTP module, custom error module, which basically handles the custom error. You may have security module here, custom error module. You may have compression module here, and caching module, logging and diagnostic logging module. So you can configure all these modules in your app using the settings. So after all these modules process your request, it comes to your handler. This is HTTP handler, which is basically your app. Here is your app is sitting, and it gets called with a HTTP context object. And that HTTP context has, so if this is HTTP context, it has two things. It has a request and response object, and these request and response have different headers on them. They're called HTTP headers, which basically tell from the client side, when client is making a call, it puts in the request header that I will accept these kind of character sets. I will accept this encoding, what language I will accept. And when a response is going back, it puts some header, like one header can be age. Age means how fresh this content is, and whether it will accept the range queries or not. What is allowed? Allow is one of the HTTP header, which says what kind of verbs are allowed, is get allowed, is put allowed or not. So that information goes through the HTTP header. There's an authorization header, cache control header, which is this Akamai may look at your cache control header and act on it. There's another interesting header is there called referrer header. When the request comes in, it has a HTTP header called referrer, which is have the information like who referred this call to us. For example, if you are in a bing.com and you're searching about microsoft.com and you get the link and you click on it, so the call is coming to microsoft.com, and in the referrer we will have bing.com. So that's how the system knows who is referring to us, and there's a lot of other things can happen on that referrer. So here's your application. It is processing all these headers, and then to get the data, it may go to DB, and this DB, before the DB, it may hit its own cache sometime to see if it already has the data. If it does not have the data, then it will hit the database, and it will go through, most probably through some stored procedure, and then finally it reaches to a table and gets the data. So after it gets the data, it bring back. So from here, this goes back through your HTTP pipeline, then it goes back to HTTP sys, your server, and then it goes to Akamai cache, hop through all these server, and then the call come back to your machine. But before it comes back to your machine, I should do this thing maybe, because before this machine it goes through this OSI layers all the way, and then it reaches to the application, and then goes through your browser, and then the rendering engine comes in picture. And that's where it takes all this HTML and render it on the DOM tree. This is called DOM tree, document object model of, or the web browser. And then it goes and shows the data to you. So this is the whole journey a web page takes, and all this happens under 200 milliseconds. So as you can see, there are so many pieces involved, but still everything happens within 200 milliseconds. Isn't science is amazing? So here we talked about a lot of components, but very high level. I left a lot of pointers here. So if you are a web app developer, you have to understand this portion where the HTTP pipeline is there. And if you are a networking engineer, you have to understand how the Akamai works, how the DNS and gateway works. And here again, if you are a system engineer or working in an operating system, you have to understand all this OSI layer. And if you are a web dev, you have to understand how the rendering engine works of a browser. So this is a quick overview of a journey of a web page on a very high level, but hopefully you got enough pointers to dig deep into certain subjects.